Good morning, AP Calculus. Today we're going to be looking at how to perform operations with functions. Make sure you have a piece of paper out and make sure you're ready to go here. Let's go ahead and get started. Our warm-up for today is find all asymptotes, find any holes, and identify the domain. So from this right here, which you should have seen before coming to class and doing the video, is this function here, f of x equals x to the third minus 3x squared minus 4x, all divided by 3x squared minus 3x. And what you should have found is that we have a vertical asymptote at x equals positive 1, and that we should have a hole at x equals 0, and that means our domain for this function is all real numbers except x cannot be equal to 0 or 1. Okay, so let's go ahead and start talking about operations with functions, starting with the first example here, which is we have two functions. G of a, function g of, with a variable a is equal to negative 2a plus 1, and f of a is equal to a squared minus 4. And it says find g plus f of a. That means all we're going to do is we're going to add g of a plus f of a. Okay, that's how we define what that is. Okay, so whenever you see something like this, g plus f of a, that means we're going to add the two functions together. So that means we're going to have negative 2a plus 1 plus a squared minus 4. And all we have to do here is combine our like terms. And the only like terms we really have are 1 and negative 4. When we combine these two, we get negative 3. Okay, and everything else stays the same. I'm going to write it in ascending order using the commutative property here. So that means, or sorry, descending order. So starting with a squared, so we have a squared minus 2a minus 3. And that's all we have. That's all we have to do here. As long as we combine our like terms, then we have performed the operation here. Okay. Another example with addition is we have function f with input a equals 4a, and g of a equals a squared plus 2. Okay, and it wants us to find f plus g of a. So once again, using the same definition from last time, if I have f plus g of a, that means I'm going to take function f of a and add it to function g of a. Okay. So once again, we want to substitute these definitions in. So f of a is just 4a plus g of a, which is a squared plus 2. Okay, once again, after we're done doing this, after we plug everything in, we look for like terms, 4a, a squared, and 2. They're not like terms, so I'm going to rewrite it again in descending order from descending powers. So a squared plus 4a plus 2. And there's my answer. Okay. So once again, the idea is you look at the operation inside parentheses, and that tells you what you're going to be doing with the two functions. The next example, if you're thinking ahead here, is now we're looking at subtraction. So in this case, we have two functions. H of t is equal to 2t minus 5, and g of t is negative 3t squared minus 3. And once again, we're going to combine here, but we're going to use subtraction. Okay, so once again, h minus g of t means we're going to subtract. So h of t minus g of t. We're going to substitute again. Now we want to use parentheses whenever we replace because of problems like this, because of subtraction. So I'll show you what I mean by that. So h of t, that's just 2t minus 5, parentheses around that, minus g of t. So negative 3t squared minus 3. Now once again, it's a rule of subtracting that whenever we subtract a number or an expression, that we use what's called keep, change, change. What that means is we're going to keep the sign of the first term. We're going to change the minus to a positive, And we're going to change all the signs of what's inside the parentheses to the right of the minus sign. So this becomes a positive, this becomes a positive. So now we have 2t minus 5 plus 3t squared plus 3. Now we can combine our like terms. Once again, just like we saw in example 1, the only like terms I have here are negative 5 and positive 3. When I combine them, I get a negative 2. So my final answer in descending order, just like we've seen already, is going to be 3t squared plus 2t minus 2. And that's h minus g of their variables t. Looking at another example of subtraction. Find g minus f of a when g of a is 4a minus 1 and f of a is a squared plus 5. Okay, so once again, g minus f of a means we're going to have g of a minus f of a. So we're going to go ahead and substitute in our functions. So that's 4a minus 1 minus f of a, which is a squared plus 5. Okay, once again, let's go ahead and apply that keep, change rule. I'm going to keep the signs of everything in the first set of parentheses, change this to a positive, and then change the signs of everything in the parentheses. So negative a squared, negative 5, and then we have everything else. So let's see what happens here. So 4a minus 1 minus a squared minus 5. Okay, and then let's look for our like terms here. Well, it looks like our only like terms are just going to be our constants again. So negative 1, negative 5. Negative 1 minus 5 is going to be negative 6. Everything else comes right down. In descending order, it looks like this. So negative a squared plus 4a minus 6. So there's our function for this example. Okay, so we've covered addition, we've covered subtraction. What do you guys think is next? Yeah, multiplication. All right. So we're going to multiply these two together. So f of g of, or f times g of n, when f of n is n squared minus 5 plus 2n, and then g of n is equal to n plus 1. Okay, so once again, I'm going to write this out. F of times g of n. That means we're going to do f of n times g of n. Okay, so here's what that's going to look like. So f of n is n squared minus 5 plus 2n, and then g of n is n plus 1. Okay, now there are multiple ways we could go about distributing and multiplying these two expressions together, these two functions together. One way that I found that is easy to organize here is using what's called the box method, which looks like this. So if you create a box, in this case we have one function that's 3 terms, another one that's 2. So we're going to split this into 2 rows and then 3 columns like this. I'm going to put f of n up top, which is n squared, negative 5, and 2n, and then n, and then positive 1 like this. And what I'm going to do is I'm going to multiply everything like it's a Punnett square from biology. So n times n squared is n to the third. Let's use a different color here. Why not? Let's be different today. So n times n squared is n to the third. N times negative 5 is negative 5n. N times 2n is 2n squared. 1 times n squared, well, that's easy. The nice thing about this bottom row being a positive 1 is that I can just take what's on the top row and put it right here. Because I'm multiplying everything by 1, that means nothing changes. All right, so now we can combine our like terms. So let's see here, n to the third is by itself. Let's see here, n squared goes with 2n, so I add that, so that's plus 3n squared. So I can cross out all my terms that I've used already. Let's see here, negative 5n and 2n, that's minus 3n, cross those out. And then I'm left with negative 5. And there's my nice little function here, my combination of f of n and g of n by multiplication. Okay. that's what goes right here. So f times g of n is equal to n to the third plus 3n squared minus 3n minus 5. Looking at another example of multiplication. Find g times h of n when we have g of n is n plus 2 and h of n is n minus 1. This one's a little bit nicer to us. So once again, g times h of n means I'm just going to break it down for you guys here. So g times g of n times h of n. So once again, the idea is that we multiply the two functions together and we combine our like terms if there are any left over. So g of n is n plus 2, h of n is n minus 1. Now for these ones, you can use the box method like we saw before, but when we have two binomials, such as we have right here, we can go ahead and use the FOIL method. So n times n, that's my first term, that's n squared. N times negative 1, that's my outside term, so minus n. My inside terms, 2n, so plus 2n. And then my last terms, 2 times negative 1 is negative 2. That means my only like terms are the guys in the middle right here, negative n plus 2n. So my final function here is n squared plus n minus 2. So there's g of h times, or j times h of n. All right, so we've done addition, we've done subtraction, we've done multiplication. What do you guys think comes next? You got it. Division. Whenever that shows up on my screen here, oh, I clicked the wrong one. Division, absolutely. G of x is equal to 3x minus 4. H of x is equal to x plus 4. We're going to find what happens when we divide here. Okay, so really all it is, as you can probably have guessed, is that when we have g divided by h of x, all that really becomes is just g of x divided by h of x. And we rewrite it just the same way as we had before. So g of x is 3x minus 4 and divided by x plus 4. Now right here, nothing really cancels out. We want to look for common factors. There's really no common factors between numerator and denominator, so this is what our function looks like. Okay? If we need to, we can find our wholes, we can find our asymptotes, but in this case, we just want to see what this function looks like with the division operation. Looking at the next example with division. Okay? So now we have g of a equals a squared minus 5, h of a equals negative 4a minus 1, g of h of a, or g divided by h of a. So once again, g divided by h of some variable a means we take g of a and divide it by h of a. So the first function, g of a, is a squared minus 5 divided by negative 4a minus 1. Once again, no common factors, don't have to cancel it, we just identify this as our new function. Two more examples. G of a is equal to 4a minus 3. H of a is equal to 2a plus 5. This is a little bit different right here. Okay? Notice how right here we now have an operation right here that is a circle. What this means right here, this g circle h, it means function g of function h. And all this really means is we're going to take g, keep doing that. I always forget to switch back to my pen. So g of h of a looks like this. We're going to take function g and we're going to make h of a its input. And here's what that looks like. I'm going to take everywhere I see an a inside of function g and substitute in 2a plus 5. Okay? So that means I'm going to substitute in 2a plus 5 for that a right here. And here's what that looks like. So that means this is going to become 4 times 2a plus 5 minus 3. And all I have to do here is distribute the 4, combine my like terms, and then I have my composition function. Okay? So that means, 4 times 2a, that's 8a. 4 times 5 is 20. Take away 3. My only like terms are 20 and 3. That means that my composite function, my composition of functions is 8a plus 17. And that's how we do it. Once again, this right here, this symbol right here means it's going to be a composite function. A function within a function. Okay? And we want to substitute in our definition for a function in for another one. Last example I want to show you. Composition of h of g of x when we have h of x equals 3x squared plus 1 and g of x equals 3x minus 2. So once again, h of g of x means we have h with an input of our function g of x. Once again, it's a function within a function. So I'm going to take my x squared, where I have this x right here, and I'm going to replace that with 3x minus 2. Here's what that looks like. So I'm going to get 3 times 3x minus 2. And then I'm going to square it and then add 1 to it. When you do that, if you multiply out correctly, you should get 3 times 9x squared minus 12x plus 4 and then plus 1. So once again, I'm going to distribute my 3. That gives me, let's see here, so 27x squared minus 36x and then plus 12 plus 1. Once again, the only like terms I have are at the end here, so running out of room on my screen here. That's okay though. So, I can go down just a little bit here. There we go. Excellent. So then my final function for my composition is 27x squared minus 36x plus 13. So all that work just to get to that function right there. Okay? Your homework for this evening is, so your homework for tonight can be found in your OpenStax textbook, and that's going to be found on page 32 and 33. So 32, what you're going to do is numbers 36, 38, and 40. And then on page 33, we're going to be looking at numbers 42, 44, and 48. Okay, so 6 problems. If you have questions, make sure you contact me at any time. Hope you guys have a great day. Talk to you soon.